Good morning, sir.
Very good morning, Vita.
Morning, sir.
Yes, Vita.
Good morning, sir.
Morning, sir.
Good morning, good morning. I'm audible now? You can
Yes,
listen
Yes,
me?
sir.
sir. Yes, sir.
Okay.
Yes, sir, you are audible.
Okay.
So you are audible,
Yes,
sir.
sir.
Front camera. What about board? Now board is visible clearly?
धीरे करता
Yes,
No,
sir.
sir.
No,
No,
sir.
No.
No,
no.
sir.
No, sir, not visible.
Actually, not today's.
Blur, sir. Blur. Write anything on it, then we will able to see, sir.
Okay. Okay. Now tell me.
Visible.
Yes, sir,
Yes,
visible.
sir. It is visual, sir.
Okay. Then okay.
Yes, sir. Yes, sir.
Okay.
Visible.
Yes, sir,
Okay.
visible.
No, sir. Who is there?
ऐसे पलों का जादू.
Yes, sir.
$35 are there. Properly same.
Startup Bali.
$39 are there. Okay.
Sir, 36. 37,
Almost
Today
38.
only
50
the
attend
system.
the class every day.
Okay. Is there Nalini ma'am? Are you listening me? Nalini ma'am?
Sir, good morning, sir.
Good morning, ma'am. Okay. I'm just going to convert you as a host, ma'am. Okay. Manage
Okay.
apply. Make host. Yes, ma'am. Okay. Now you are host. After 2 minutes, I can start the class. It's 8:34. I'll wait for 8:35. Then after, I'm going to start. Hello. Okay, Nale ma'am.
Yes, sir.
Okay. Can I start the class now? It's 8:35.
Yes, now you start. But
Okay.
I will close at 8:40.
Yes. Okay, ma'am. Okay. Very good morning to all of you. In the previous lecture, we have seen about rigid body, type of rigid body, and torque, moment of force, right? Then after couple, and now today we have to see what principle of moment. The topic which I have taken today, principle of moment. Principle of moment. Right? Now, what about the principle of moment? Any rough idea? No. Principle of moment. That means if a body can rotate around any pivoted point, this then moment of left side is equals to moment of the right side, right now. Then it is said to be principle of moments. Now I'm just going to define it. When our body is in rotational equilibrium, suppose that
और खुदुर
any
खुदुर
meter
करते
scale
रहो.
we have, right? We can take a uniform meter scale which can rotate through a
हाँ,
pivoted
1 रुपया
point,
दे के 2 रुपया दे के ले
that
लो.
is C. Suppose that it is hanged from a rigid support, right? This one is a uniform meter scale, nothing that. This is meter scale. Okay, so now suppose two weight. We have hanged two weight
हाँ,
with the
सिर्फ 2
help of
रुपया
a
देना.
spring.
उस दिन 10 रुपया दिए थे.
Okay, okay. These are the two weight which are hanged with the help of a spring. Suppose that its weight is what? W1 and its weight is now suppose that W2. This point is pivoted point, through which pivoted point is a point through which a body can rotate, right? And assume this point also. Suppose that this distance is the distance of this weight from this pivoted point. Suppose that that is W1, and this one is, sorry, this is D2 D1, and this one is D2. Means the distance of where the weight you have had, right, through a spring, balance a spring. This distance from the pivoted point is, suppose that D1, and in the same way we can assume this distance is D2. So according to the principle of moment, what? The sum of clockwise moment. What about the principle of moment? The sum of clockwise. Clockwise means in this direction. The sum of clockwise moment is equals to the sum of anti-clockwise moment. Anti-clockwise moment. What about the principle of moment? According to this principle, according to this principle, what? Sum of clockwise moment is equals to anti-clockwise. Sum of anti-clockwise. Sum of anti-clockwise moment. That is the principle of moment. What about the, suppose that number of weights? Here we have hang only one. You can hang 2 or 3 more, right now? More. So, and suppose that their distances are D1, D2, D3. The same way we can assume D4, D5, whatever. Any distance we can assume. X1, X2, right? A1, A2, A3. So, principle of moment means what? The body is in, when a body is in equilibrium, it will, when a body is in rotational motion, it will be equilibrium during, suppose that any body that can rotate around a fixed point, that is called pivoted point, right? It will be equilibrium. It means what? What about the moment of force is acting on the left side, that will be equal to the right side. So it means what? The moment of the left side is equal to the moment of right side. Whatever the moment of, suppose that 2, 3, 4 moments are working, right? This side and this side also 2, 3, 4 moments are working. So their sum will be equal. That is the principle of moment. In simple, we can say the sum of clockwise moment. If the sum of clockwise moment is equal to the sum of anti-clockwise moment, then it is said to be the principle of moment. Right? How we can calculate? Now, suppose that let W1, W2 are suspended from D1, D2. Right? Suppose that W1 and W2 are suspended from D1 and D2 from the pivoted point, then from a pivoted point C, then anti-clockwise movement about C. So anti-clockwise movement about C. C is a pivoted point. About C is what? This one is anti-clockwise. That is, so force F1, force into perpendicular distance, right? If weight is working here, we can write also W1 into D1, and clockwise moment about C is what? Clockwise. This one is clockwise. That is the clockwise. So here, suppose that the force is W equals to what? Mg. So this one, suppose that force is working F2, and what about the distance from the rotational point, from the pivoted point? That is D2. We can also write it W2 into D2. According to principle of moment, according to principle of moment, principle of moment, what it should be equal? F1 into D1 is equals to F2 into D2, or we can say W1 into d1 is equals to w2 into d2. That is the principle of moment. We have to see number of numerical related to this principle, right? Now, and after that, any problem over here? Any one of you can reply me?
बंद है
Okay.
ये नीचे रखा है ठीक है दो
Hello. Hello. Nalini ma'am?
Yes, sir.
Okay, okay.
Hello.
Yes,
Sir,
yes.
Tanish Gupta has some problem.
Okay. What's the problem with them?
I have asked. Tanish Gupta will ask something.
Okay, okay. Let them ask, ma'am.
Sir.
Yes, ma'am.
Yes, Tanish, you ask.
Excuse me, sir. Sir, the lower
Yes.
board was not visible, so sir, write it upward what you have written downward.
Okay, okay. So, what was okay? Just time to write. I'll repeat that. So, what we have written in lower board, that written, say according to principle of moment, according to principle of moment. What was the principle of moment? As you know that sum of clockwise moment equals to sum of anti-clockwise moment. So what was the anti-clockwise moment? That is F1 into D1 is equals to what was the clockwise moment? F2 into D2, right? We can also write it W1 because we have hand away W1. So at the place of force F1, we can write W1 into D1 is equals to W2 into D2. That is a principle of moment, right? Get it? Okay. Now, next topic we have, very important topic. Today we have to take uniform circular motion and 2-3 topic related to there. Then after we will see the gravity and the chapter will be finished. So what about the uniform? Very important topic. Uniform circular motion. Uniform circular motion, right? What type of motion is said to be uniform circular motion? Any rough idea? I can give you example, hint also. Right now, the motion of fan, motion of earth around sun, motion of moon around earth, right? Motion of needle of the wall clock. These all are the example of uniform circular motion. So any rough idea how it can be defined? No? Okay. When suppose that they all are rotating about a definite path, we can also say that they are in circular motion. Right now, every particle of that body is rotating about a definite point. That means they form a circle. Right now, when a body, suppose that if this point is fixed, right? That is the pivoted point through which a body can rotate. If this body is rotating about this point, suppose that if this one is rotating, then it will form a circle. And suppose number of particles, suppose that many particles are there, then they are also rotating, so they will form a circle. So every particle, when a body is rotating about a definite point, then every particle on that body form a circle. And if their speed remains constant the entire journey, then it is said to be uniform circular motion, right? So, okay, let O be the center of this circular path. If a body is rotating with a constant speed, their velocity will change, but speed will be constant, right? See here, everywhere. Okay, every time during the journey, their direction is going to change continuously, so their velocity will change, but speed remains constant. Here, speed, right, equals to what? Constant, remains constant. We can write. constant. But velocity cannot be constant because of their direction. No? So, when a body is rotating on a circular path with a constant speed, then its motion is said to be uniform circular motion. Right? I'll repeat it. When a body is rotating on a circular path with a constant speed, then its motion is said to be uniform circular motion. Now, we have a question. Number of questions we have. For example, if you want to say, then how many examples I have given you? Many more examples, right? Example, motion of, what are the example of uniform circular motion? Motion of Earth around sun, motion of moon around Earth, right? Motion of fan, etc., etc. Many more examples are there which are rotating, which are moving in a circular path with a constant speed in nature, right? Okay. Now we have to see. You could understood if their speed remains constant, then there is no linear acceleration. Which type of acceleration? Linear acceleration. We cannot because it will be zero. Why? The linear acceleration, when a body is in uniform circular motion, linear acceleration of the body is, it will be zero. Why? Because their speed remains constant, no change in speed, so its linear acceleration will be zero. But their direction, but its velocity is changing continuously. So therefore, there will be acceleration directed towards the center of circular path, and this type of acceleration is said to be centripetal. Which type? Centripetal acceleration. Right? In that sense, centripetal acceleration. Okay, centripetal acceleration. AC is defined. It's a formula if you want to know. So I'll tell you V square by R. You can say R omega square. Even it is not in your syllabus, but I've told you for your knowledge only. Right? V is a linear velocity. Is a velocity. Right? R is what? Radius of the circular path. That is R. Right? And here, where V linear velocity and omega equals to what? Angular velocity. When a body is rotating about a definite point, then the velocity of the body is said to be angular velocity, or you can say the rate of change of angular displacement is said to be angular velocity, right? And R is what? Radius of the circular path. Radius of this circular path. Okay. So, and what's the relation between, if you want to know what about the relation between linear velocity and angular velocity, any one of you can ask me, so what is linear velocity and what is angular velocity, and then I'm just going to write the formula related to that, right? So linear velocity, most of you know very well. Linear velocity. Linear velocity equals to, it is denoted by V. V is equals to what? Delta S by delta T, right? That means rate of change of linear displacement is called linear velocity, right? Its unit, any one of you, meter per second, as you know. In MKS system, in CGS, centimeter per second. And next one, angular velocity. Angular velocity. Angular velocity, it is denoted by omega. Angular velocity is what? When a body is rotating about a definite point, then it rotates in angular form. So the rate of change of angular displacement, that is angular displacement. That displacement in the form of angle, suppose that theta 1. Now suppose that theta 2. What is the angular displacement between, suppose that point is P2, this one is P1, that is P2. So what is the angular displacement between P1 and P2? This angular displacement is theta 2. This one is theta 1. So it will be theta 2 minus theta 1. It is said to be delta theta. Suppose that it will take time interval delta t. Right? Its unit. What about unit? Angular is a radian. What is the unit of angle? Radian per second. Okay. So angular velocity is denoted by delta theta by delta t. This one. Get it? And any one of you, if you want to know, so what's the relation between them? I'm just going to tell you. Okay. V is equal to R omega. Relation between V and omega. That is right. This topic we have. So that is V is equal to R omega, where V, that is the relation between linear velocity and angular velocity. How we can derive it is not necessary for you. In 11th standard, you derive it. Here, I'll told you only the formula. Even it is also not in your textbook, but I'll told you for your knowledge only, right? So that is the relation between linear velocity and angular velocity. Okay, now, if a body is rotating on a circular path with a constant speed, then it is acted if there is an acceleration directed towards the center of circular path. If yes, any one of you?
Sir,
Yes, sir. Yeah, you can ask me, no problem.
thank you, sir.
Okay. Let me complete only two topics: centripetal force and centrifugal force. Then I'll give you time. Okay. So, what topic we have to discuss? Centripetal force. Centripetal force. It is audible now, everyone? Any one of you can reply me. It is audible or not? You can hear me? Okay. So centripetal force. What about the centripetal force? When a body is in uniform circular motion, right? When a body is in uniform circular motion, then you know that the acceleration is directed towards the center of circular path. Suppose that any body is in circular motion, uniform circular motion, right? Then you know that there is no linear acceleration. Only acceleration will be directed toward the center of circular path. This type of acceleration is said to be centripetal acceleration, right? So if there is acceleration and suppose m be the mass of body, then what will be the force directed? What will be, you know that, what will be the direction of acceleration? There will be the direction of force. So what about force? Centripetal force, Fc equals to mass of the body and centripetal force which is acting directed toward the center of circular path. So you have mute them. Who is any one of you asking something or you have on their loudspeaker? Hello? Okay. So Fc equals to m into AC. F equals to, according to Newton's second law, you know that force equals to mass into acceleration. So mass, we have suppose that the body of mass, the body which is rotating, suppose the earth is rotating around sun, then we have to consider the mass of earth and we have to take the centripetal acceleration which is directed towards the center of circular path towards the sun, right? So Fc equals to m into AC. Put the value Fc equals to m. If AC equals to AC, I have told you what the formula of centripetal acceleration. AC equals to, in term of linear velocity, v square by r, and in term of angular velocity, r omega square. So it will be either mv square by r, or we can write it m r omega square. These two are the formula for the centripetal force. Okay, its unit. If you want to know, so what about its unit? That is same as that of any force. That is Newton. Okay. Now, centrifugal force. Very interested and very important topic for you all. So, what will be the direction of centripetal force? What will be the direction of centripetal force? Directed towards that is the directed towards the center of circular path, right? And what will be the direction of centrifugal force? Before going to say this, we have to understand what is the centrifugal force. Okay. We have seen many of the places. There are some certain situation. I'm just going to define. There are some certain situation in which we feel that the body is rotating on a circular path, right? But in actually, that body is not rotating on a circular path because it is placed on some object, and that object is rotating. Due to this, it is also rotating. For example, in a doctor chamber, if you are sitting on their chair, that's a movable chair. When he rotates the chair, you will also turn. So that chair is turning around a point, due to which you are rotating, right? Any other example I'll give you? Any problem? Any one of you? Just tell me whether it is audible or not, visible or not. Give the feedback only. Any one of you can reply. Monitor of this class,
Yes, sir.
please give a feedback. It's audible?
Yes, sir. Yes, sir.
Clearly audible, not visible?
Yes,
Okay.
clearly.
Yes, I need only that button. Actually, I'm just teaching many more topics, but if you are not responding me, then how I could understood that you are getting a lot. Okay. So, centrifugal force. Centrifugal force. I have told you. What about the centrifugal force? Suppose that any object, any object, which can rotate around a definite point. If any, right? This one. Suppose that is a circular table. In a doctor chamber, you have seen on a stand there was a circular plate at which the patient will be is to be seated, and it that circle can turn here and there. So that means it is turnable, movable, right? So if a body is here, suppose we have placed any body, and this one is rotating. Suppose that circle is disk is so anything you can assume. This one, yeah, Earth is rotating exactly. One more example we can take. Earth is rotating about a definite point, right? Now, the direction of the rotation of the Earth is what? Towards west to east. And we are also at the surface of Earth, but we are not rotating. We cannot feel that we are rotating or not, right? So this body is not rotating. It is placed here. That's why it is rotating. Because suppose that anyone has applied any force, right? And it is rotating about this point. That suppose this one is the entire. This is total. This one is a body, right? It is rotating about a definite point. That is, that rotational point. If any object is placed here, suppose that we have placed any chalk, marker, etc., duster, anything, right? When this one is rotating about a definite point, then this is also rotating about definite point, right? So the direction of centripetal force is directed towards the center of circular path, but this body is not rotating. This is rotating because of the rotation of this table. So this force is working outside of. The magnitude is equal to the centripetal force. What will be centrifugal force and centripetal force? They both are by their magnitude. They both are same, right? Their formula will be same. Only what will be the change? What is the difference between them? Only the direction. Its direction is outside of the center, and centripetal force is inside the center. Right now, suppose. Have you seen our separation of cream from the milk? When even by using this one, centrifuge, it's a device also. I want to discuss you. It's very centrifuge. Any one of you, have you ever seen this one, centrifuge? It is a device, right? Now there was also a handle you have seen in dairy farm. Right now they rotate it's very rapidly, and again it's begin to rotate. The milk is filled in that side. During the rotation, what will be the process? I'm just going to explain you. As you know, in a milk, cream particle and milk particle both are there. Cream particles are lighter than the milk's particle, so they adopt the lesser radius and rotate towards the center of circular path. And milk particle are heavier particle and compared to the cream particle, so they adopt the larger radius and goes towards the